Hello and welcome to today's video. All right, so we are on our second question in the series that we have solving 100 versatile integration question. So today we have the function x exponential x sin x dx that we have to integrate, and we are going to be making use of integration by part to actually solve this amazing question. So we'll start. So we'll start, and we already know the method we are applying, integration by part. So I'll write the formula. So integration by part. That is integral of u dv equals to uv minus integral of v du. All right. So the function we are integrating, we have this sin x dx. So how do we know which one will be our u and which one will be our v? So we'll go back to our knowledge of light. And in this case, we have an algebraic function before the trigonometric and the exponential function. So it means in this case, my u now will be x, and then my dv will be equals to exponential x sine x dx. So if I go ahead to find the u dx here, I'm going to have 1, and that tells us something. By the time I cross multiply, this just tells me that the u is actually equals to dx. So I'm done with this side. So then I go ahead to find the value of v, because I need v to be imputed into the formula that we have above. So we'll say that to get the value of v now, I'll have to integrate both sides of this equation such that this now becomes v equals to integral of exponential x sine x dx. All right, so you cannot get a straightforward answer to this. The way you integrate sin x and you get minus cos x, or you integrate cos x and you just get sin x, you do not have just a direct answer like that. So we have to actually solve this part of the equation again. So I'm going to label this star, and then we're going to go ahead to say solving star now. So we want to solve this part, right? And I'm going to use the same approach. But right now, instead of using u and v, in order not to complicate things, to confuse us, so I'm going to use f and g now. So this is the idea. We're going to be doing integral of what? F, right, dg equals to fg minus integral of what? That will be g now, right, df. Right. So which one will be f, which one will be g? So in order to know, all you have to do again is go back to our light. So we see that trigonometric function comes before exponential function. And that means that in this case, f now will be the trigonometric function, which is sine x, and then g now, the g rather, will be exponential x dx, because by the time this is f, it means everything you have left will be dg. I hope we got that. All right, so here we can go ahead and say, all right, now, so the f dx will be equals to cos x, because if I differentiate sine x, I'm going to get cos x. So, I mean, this tells us one thing. This tells us that the f now will be equals to cos x dx. All right, so I also have that the g is equals to exponential x dx. And to get back the value of g, of course, I'm going to integrate both sides, and beautifully, I can get my g to be exponential x. If I integrate exponential x, I'm going to get exponential x. All right, so I have I have f, I have df, I have g, and I have dg. So all I have to do is come back and put it inside the expression. So I'm going to go and say, therefore, integral of exponential x sine x dx is equal to, so we know this is fg. So this is f, which is sine x, and g, which is exponential x. So fg minus integral of g, and that g in this case is exponential x, then df. This is df right here. So that is cos x dx. Right, so we see that this can now be exponential x sine x minus integral of exponential x cos x dx. So this is equals to this. Now we'll look at this and carefully we'll see that we still have this integral. So what can we do? So instead of going through the process of saying this is f and g, we are going to just use a direct and straightforward shortcut. So this can be exponential x sine x minus. So I know that this now, because x in this case now, let me change my ink. So we know that the cos x in this place now will be our new f. Same way we say u, because if we go back to Layet, right, trigonometry comes before exponential. So we'll say this is u cos x, and then this will be, right, the v, or as we have it, that will be the g, since we are using g. So the g, so it means I'll have this guy to integrate. So if I integrate that, I'm going to get exponential x minus integral, right, of, then what will this guy be? This guy now, if I differentiate this guy, I'm going to get minus sine x and then exponential x. So this is something you can try out using the same notion we've used while solving the question from the start. So this now becomes exponential x sine x minus, into bracket, exponential x cos x plus integral of exponential x sine x dx. Now you see, this is very, very interesting because I'm going to expand this bracket now, and you realize that we have exactly the same thing on both sides of our equation. So this is this. I mean, we are going to have something common now, and we are going to see that. So minus exponential x plus x. The minus is going to open this also, minus integral of exponential x sine x dx. So you see, if you look at this, you see this and these are the same, right? So I mean, I'm just going to say let I just be integral of exponential x sine x dx. So going back to this, I'm going to have I now is exponential x sine x minus exponential x cos x plus I, right? I mean, that should be minus I rather, sorry. So let's change this to negative I. So if we refer to what we've been solving from the start, so this is negative I. So I'm just going to collect my like terms. So the negative I goes to the other side, and then I have I plus I now equals to exponential x sine x minus exponential x cos x. So I plus I, of course, is 2I. Then this equals exponential x sine x minus exponential x cos x. And if I divide both sides by 2, I'm just going to have that I is exponential x sine x minus exponential x cos x over 2. So interestingly, if we look at this, that is this v that I'm looking for. So I am now sure that v, so I'll say from star now, v now is equals to this I. So v is exponential x sine x minus exponential x cos x over 2, which is amazing. That is very, very much amazing. So we can now go back, right, and solve for the original expression that we have. So we can now say that, therefore, integral of x exponential x sine x dx now can now be equals to, in this case, u is x. So I'm going to say x. And then v now is what we've got in here. So v now is, I'm going to say exponential x sine x minus exponential x cos x over 2. So uv minus integral of v, which is this guy, exponential x sine x minus exponential x cos x over 2, then d, if you look at this, then you have du, but du is equals to what? Dx, if you recall. So I'm just going to put dx here. So to make our work easy, this can be exponential over 2. I mean, x, I can bring out exponential x as well over 2 because those are common terms, right? So I'm going to be having sine x minus cos x. Then I can easily bring out the 2 at the denominator. Please do not bring out exponential x in this case because we are actually integrating with respect to x. That would be a disaster. So we have minus 1 over 2 integral of exponential x sine x minus exponential x cos x, right, dx. So I can say this is x exponential x over 2, then sine x minus cos x. Then I can expand with this half so that this becomes minus half x exponential sine x exponential x sine x. Then I put dx plus half, right? Integral of exponential x cos x dx, right? So we have this. Interestingly, we have this. So if we go back and decide that, all right, so we want to solve this integration, I think we have one of these two. So I'm just going to go back and check what I have when I integrate one of these two. So I think when we integrate this lovely guy, exponential x sine x, we have this. We have this. So this is say x exponential x over 2 sine x minus cos x, right, minus 1 over 2. Then we integrated this guy, if we remember, right? That's what I was saying. We integrated this and we were able to get this. So I'm just going to pick that up and put that here so that we have a exponential x, right? Sine x minus exponential x cos x over 2. So we have that for this guy. Then plus, I'm going to do my 1 over 2 here. So if I integrate this guy, so we are going to quickly do this, right? So we know that in this case now, this is our u, right? Our u will be cos x, right? Then I'm going to differentiate this. So I have exponential x, right? Minus the integral of, then I have cos x, the integral of cos x, which is negative, the differential of this, so negative sine x. If I integrate that rather, then exponential x. Okay, so I think we are getting there. Sorry. All right, so yeah, trying to create a new slide. All right, so yeah, we can go back and say we then have our last equation, our last expression looked like, okay, x exponential x over 2 into sine x minus cos x, right? Then minus half that again, minus half exponential sine x minus cos x over 2, right? Then plus half. So we have plus half, and then we have exponential x cos x, right? Then minus, we have minus times minus will give us a plus, minus times minus is a plus, so plus exponential this sine x dx. So we have this, all right? So we are just going to do this. So this will be x exponential x over 2 sine x minus cos x minus 1 over 2 exponential x sine x, right? Don't forget this guy, minus exponential x cos x over 2 plus, this will now be half exponential x cos x plus half. Now, you will recall that we've actually integrated this, and this is also giving us the same thing, sine x minus exponential x cos x over 2, right? So I'm going to add my integral constant plus c, right? Now, are we done? No, not yet. So if you look at this term and this term, you'll notice that they are the same. So I can say this cancels out this, and at the end of the day, I'm going to have x exponential x over 2 into sine x minus cos x plus half of x exponential cos x, right, plus c. Yeah, and of course we can leave an answer like this, or you can go ahead, to factorize for that, since we have exponential x cos x here, exponential x. So I'm just going to leave my answer like this, right? I hope you gained something in this video. It's something that I would love if you actually take time to walk through. You would have gained a few things. I would love to actually hear what you've gained in the comment section, and yeah, watch out for our next video. I'll see you on the next one. Thank you.